Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology, and everyone, welcome into the program. I hope that you're doing well and you are ready for today's show, because today on the program, you may have guessed it, it is Ralph Bond. He joins us every Friday, excluding last Friday. He joins us every Friday to talk about amazing stories that you definitely want to hear about. Although I will say that this week's stories, if I had to put a theme to it just by reading through it, what's old is new again. And by that, I mean geothermal, sailboats, and tweezers. Ladies and gentlemen, those things that you may have heard of, we're going to give a new spin to it. So these are going to be amazing high-tech stories that you probably haven't heard of. And computeramerica.com. That's where you'll find everything, including the show notes that Ralph puts together for this. And they include everything, including the links, the articles, when applicable, the research papers, everything and more. And ladies and gentlemen, computeramerica.com. It's all you need to remember for this show. So with that being said, let's go ahead, bring Ralph on, and just have fun with it. So once again, science and tech trends correspondent, what that means in just a moment. But everyone, welcome back onto the program. Ralph, how you been?
I'm doing great. It's great to be back in our house after a catastrophic water leak due to a little tube that feeds water into your refrigerator. Here's a public service announcement, everybody, before we get into the show. Please, if you have a refrigerator that does water and ice dispensing, has a water line that feeds it, pull your refrigerator out, take a look. Make sure you have high quality metal encased braided metal lines, because we had a line fail because it was a cheap, crappy thing, and it sprayed water while we were gone, of course, for a week. Come home to a giant puddle, had to have the floors replaced downstairs, and we're finally back into our house. So there's our public service announcement before we dive into the show. But as Ben was saying, every Friday, what he and I do is we look at 4 articles that show us key trends and developments in all things science and technology, including almost every story includes artificial intelligence. And we look at robotics, medical technology, sustainable energy technology, transportation advances, agricultural tech, construction tech, space research, physics, on and on and on. But here's the key, folks, most important of all, and boy, do we need it this week. We're going to give you hope for a better future thanks to amazing breakthroughs happening every day in the world of science and technology.
Yeah, I think we could all be uplifted by a little bit of, really cool, amazing stories. And just to chime in just one more time on the whole hose thing, from my experience, like most come with the default kind of plastic tubing you'd find for like fish tanks and whatnot. Over time, the hot air from the fridge dries it out, makes it crack, makes it brittle, and then eventually it will snap on you just like it did for Ralph.
There
just
you
like
go.
I recommended for Ralph, and I recommend for everyone out there, because we're a technology show. They now make water sensors that you just put on the floor, powered by battery, and you can even get them connected to your phone, or I should say Wi-Fi, and they will alert you if any moisture touches those sensors. So check out that as well.
Right on target. I have a set of these devices after this horrible thing happened. Good old Amazon, classic thing. Found it. Happens to be Yo Link is the name of the company. There's many other great products out there too. Little tiny cube-like devices that I just place in different strategic things, under the kitchen sink, near the dishwasher, under the refrigerator, and toilets, and so on. I have them all over the house now. And to your point, Ben, if water makes a connection, it makes an audible sound if you happen to be in the house, or I could get an alert on my smartphone basically wherever I am, so long as your internet is working at home and your network is working at home. But a great tip for water damage prevention.
Yeah, because it's the one thing everyone loves is just another connected device that they have to keep track of.
Hmm.
But hey, it could save you a lot of headache, and
Oh, yeah.
always love to kind of key people in on that stuff. But
Yes.
hey, we're here to talk about stories, and as I said
Yes,
before,
that.
yeah, these stories are they're very cool, and again, they're new spins on old things.
Yes.
But yeah, this is story number one is really really indicative of that because yeah, we've covered something like it on the show before, but hey, this is a whole new article with some new implications and some updated information. So Ralph, let's talk about sail ships or ship
Yeah, yeah.
sails.
In fact, the first two stories today pick up on something you and I reported when it was in research stages and now is being deployed in the real world. So this is a great way to kind of revisit a couple of topics. And the first one comes from interestingengineering.com, one of my favorite go-to sources. Headline: Giant 150-foot wing just set sail on a 754-foot cargo ship, and the ship runs in part on wind. And this is a pickup. We looked at the research into these kinds of rigid sails, if you will, for cargo ships. God, a couple of years ago, I think. And now we're beginning to see it really being deployed in the real world. This is pretty cool. And again, if you have the show notes, we have the links to the articles. We have a link to the company's website. In this case, really good resources. Check this out. This is a trend we're going to see because, well, I don't know. Would these rigid sails help ships get through the Hormuz Strait? I don't know. I would like to think it could. But anyway, getting into the story, a Swedish company called Oceanbird has installed a giant rigid wing sail called Wing 560 on a cargo ship called Tirana. And we have a picture of that in the show notes, along with the links as we mentioned a second ago. Now, the wing is about 150 feet tall and is designed to help push the 754-foot, 230-meter ship using wind, reducing the amount of fuel its engines need to burn. And here's the key. It's the first real-world demonstration for the EU-backed Orcell Horizon project, which aims to build cargo ships that get over 50% of their propulsion from wind. Think about that, Ben. That's a huge goal.
Yeah, that just makes everything more efficient, and this green energy, kind of reduce, reuse, recycle, global warming, that kind of the whole thing aside, just making everything cheaper and easier and better. Like the positives are really all around. And hey, it's a technology that worked for hundreds and thousands of years. So
Yeah.
Ralph, it kind of makes sense that we kind of turned back to it because we kind of said, wind, old hat. We have steam engines, we have gas engines, we got all this stuff, but the wind's always still just right there. So why not pick up on it?
Exactly. And in the show notes, by the way, when you see blue text, those are inserts I put in to add to the stories that I'm giving you highlights from. And you can see an insert about this Orcell Horizon project, which is very interesting. So you can check that out if you're interested. But going back into the story here, unlike traditional fabric sails, the Wing 560 is made from rigid materials and works more like an airplane wing, which is an interesting concept. It automatically adjusts using the help of an AI system to adjusts its angle to capture the wind efficiently and can tilt down when the ship needs to pass under bridges or during certain operations. And let's get into the role of AI-assisted control software in this scheme. So it's more than just the rigid sail itself. It's a smart sail, if you will. The AI software continuously monitors weather conditions. The system analyzes wind, speed, wind direction, the ship's heading, and other environmental data in real time. It automatically adjusts the wing. The 150-foot rigid wing rotates to the optimal angle, similar to how an airplane wing changes its orientation to generate the greatest forward thrust from the available wind. and it coordinates with the ship's engines. This is really cool. The software determines when wind power is sufficient and when the engines need to provide more propulsion, helping minimize fuel consumption while maintaining desired speed, and finally, optimize performance over time. This is also interesting. It's like a large language model learning and gathering more. Data collected during voyages is analyzed to improve the control algorithms, allowing future voyages to achieve better fuel savings and more reliable operation. Wow.
And by the way, you included a link in the show notes once again for those who want to go check it out. Highly recommend their website because it really shows, kind of it in different positions and what it looks like, and gives some more fine detail of this thing. But it's super cool, the way that it works. And when you think sail, the big sheets, but no, this is definitely a wind sail for the 21st century.
Exactly. Hey, Ben, sorry for the interrupt, but I'm getting intermittent on my side. Your vocal is coming in buzzing and crackling, not all the time, but intermittent.
I will reset some stuff, but you go ahead.
Yeah, okay, cool. So engineers, to wrap this story up, engineers expect the wing to cut fuel use and carbon emissions by about 10% during normal operations. Now, that's at this early stage of this deployment of this technology. Again, the project aims to have 50% use of wind to propel cargo ships. That's a future goal. And a team of specialists is currently monitoring the ship to collect real-world performance data, which will help improve the technology for future vessels. So again, a key trend to watch, the deployment of these smart, AI-driven, rigid, wing-like sails on cargo ships to cut down on fuel consumption. Pretty cool stuff.
How's that sound to you?
Yeah, there you are. You're back.
Yeah, so everyone, sorry for the technical difficulties, and let's see.
This is reality podcast. It's okay.
Yeah. No, it's fun. It's fun. Real quick, and then that, and we'll just hope that works on my end. Okay, Ralph, we're going to just, while I keep tweaking stuff over here, we're going to jump to story number 2.
Yes.
Story number 2 is once again, what is old is new. I think geothermal is a pretty established technology.
Yes.
But I've never heard of a super hot geothermal.
Yes.
So let's
and
talk about this.
This is great also because it builds on research and technology developed by MIT that you and I talked about maybe a couple of years ago. And now here in Oregon, by the way, long-term listeners know I live in the Portland, Oregon area. In Central Oregon, they're going to be building this first ever Superhot Geothermal power plant. So that's the nature of this story. Now, this comes from an interesting outlet I've not dealt with before called ESGtoday.com. And the ESG stands for Environmental, Social, and Governance. Really interesting website. Check it out. And again, the show notes give you all the links. So let's get into this story. Okay, here we go. A side note. There's approximately 673 operating geothermal plant units worldwide at the end of, say, 2025. So the number may be increased now, but that's pretty amazing. 673.
Would not think it'd be that many.
Well, yeah, that is kind of surprising. So Houston, Texas-based Quaise, that's Quaise Energy, Quaise Energy, has raised $134 million to help build what it says will be the world's first superhot geothermal power plant. The money will be used to develop Project Obsidian in Central Oregon and continue improving the company's advanced drilling technology. Unlike traditional geothermal energy, which uses naturally hot underground water and rock, Quaise aims to reach much deeper and hotter rock with temperatures between 300 degrees Celsius and 500 degrees Celsius. Now, to translate that into Americanese, that's 572 degrees Fahrenheit up through 932 degrees Fahrenheit. That's hot. And to do this, Ben, the company uses a unique drilling system based on millimeter wave technology originally developed through research at MIT. That's the reference I was talking to maybe a year or 2 years ago. We talked about MIT's breakthrough in this, and now we're seeing it deployed.
it always takes just a little bit of time, but eventually, this research stuff does come to market. But yeah, it's
That's
always
right.
fun seeing MIT. And it's amazing how many of like spin-off companies come directly from MIT.
Oh
Started
gosh, yes.
as a pilot project from MIT, and then they become a company that we hear about later.
Absolutely. No, MIT is a stunning daily miracle. So going on here, instead of relying only on conventional drill bits, the technology uses high frequency energy to melt or vaporize rocks, allowing wells to reach greater depths. And in the show notes in blue text, I have a little side note about millimeter wave technology. Very interesting. In fact, I'm going to read a little bit of this because it just kind of blew my mind. So it says here, millimeter wave technology grew out of MIT's pioneering microwave radar research during World War II, enabled by the British cavity magnetron and expanded through decades of radar and high frequency electronics developed at MIT's Radiation Laboratory and Lincoln Laboratory. All the way back to World War II, this initial kernel of the technology, and then over time leads to this ability to melt and vaporize rock. Okay, guys.
I mean, it seems like a noble way to use it.
Absolutely. So accessing these hotter underground temperatures could make geothermal energy much more powerful and efficient than current systems. And here's how it works. Water pumped into these deep wells will absorb the intense heat and return to the surface as high pressure steam. That's not unusual. That's how other geothermal systems work as well. But the key again is this whole ability to drill much, much deeper into the earth. That steam in turn will spin turbines connected to electric generators, producing clean carbon-free electricity around the clock. That's the key, around the clock. Because the rock is much hotter than in traditional geothermal systems, each well can generate far more power, making Project Obsidian, this Quaise technology effort in Central Oregon, a reliable source of always-on renewable energy. And if successful, Project Obsidian would demonstrate that superhot geothermal energy can provide a dependable source of carbon-free electricity almost anywhere in the world. Hooray!
There we go. No, it's really amazing that they're able to do, that. And again, I'm sorry, messing with settings here on the background, but no, hopefully making it easier, more efficient. You don't need as many of them, but when you do fire them up, they are just super, super efficient. That's what you need going forward. So
Yeah,
fingers crossed, more of this.
there it is.
So story number 2, story number 3, and again, I said tweezers at the beginning, very tongue in cheek, because this is something that is not a normal pair of tweezers, and they're
No,
not doing something I have honestly ever heard of. So
me
story number
too.
3, very, very geeky.
Yes, it is very geeky. And like you, Ben, I had never heard of this technology before, and it's absolutely stunning. So here's the headline: AI driven optical tweezers sort hundreds of particles per hour without humans. Now, this comes from an announcement from the University of Gothenburg. So they just assume you're hip, you're a super scientist, and you understand all of this. Of course, no. We're going to try to make this as human as possible for people like me. So in the show notes, of course, we have a link to the original announcement. We have a link to their research paper, all that good stuff. We have an image of the system in question, which is very interesting looking in its own right. So let's get into this. Researchers from the University of Gothenburg and Chalmers University of Technology, so it's a coalition, have developed an artificial intelligence system called Smart Trap that can operate optical tweezers without human assistance. So normal human like me, I go, optical tweezers? What's that? Well, in the show notes, I have a blue section that says, scientists use optical tweezers to trap, hold, and manipulate extremely small objects down to single molecules using the forces from a highly focused laser beam. How does a laser beam work like tweezers and not destroy the thing it's trying to manipulate? Give me that. They're a core tool for precision experiments at the micro and nano scale across physics, biology, chemistry, and quantum science. I knew nothing about this before reading this story.
Yeah, no, this is all new technology to me. I'm sure a lot of our listeners, but no, I'm sure it will, do something useful by sorting those atoms. I don't even know.
Yeah. So back to the story here. Optical tweezers are highly focused laser beams that can grab and move objects thousands of times smaller than the width of a human hair, including DNA strands, cells, and tiny particles, even at the molecular levels we mentioned a moment ago. This technology has been an important scientific tool for decades and even earned a Nobel Prize in Physics in 2018. And in the show notes, if you want to know about that Nobel Prize and the person responsible for it, check it out. It's more about optical tweezers. Now, back to the article. Traditionally, optical tweezers require a skilled scientist to carefully control every step of an experiment. That makes the process slow, labor-intensive, and prone to small differences from one operator to another. SmartTrap changes that by combining AI, deep learning, image analysis, precision electronics, and automated fluid handling. The system can locate microscopic particles, trap them with nanometer precision, perform measurements, and automatically prepare the next sample, all without human intervention. Wow. In testing, SmartTrap sorted and analyzed hundreds of particles per hour. It successfully performed difficult experiments such as stretching individual DNA molecules, measuring the stiffness of red blood cells. What? And studying tiny electrical forces between microscopic particles. Holy smokers. Depending on the experiment, the AI completed tasks 10 to 100 times faster than a human researcher while matching or even exceeding the accuracy of experienced operators. Imagine that, Ben.
Yeah, no, it's so hard to imagine how even 1987 they said when they started doing this how labor intensive that was and how they did this before AI, and it just seems like such a natural handshake between the two technologies now.
Absolutely. And you're going to love this next passage from the article. This is where you stand up and go, hooray. The researchers have made SmartTrap open source so other scientists can build upon it. This is one of the things I love about science research is so often collaborations between different nations, different cultures, and so forth. And then the idea of making it open source, saying, here it is to the world. Let's keep working on it together as a community of thoughtful scientists. How I wish they were running the world. Anyway, they believe AI-powered laboratory systems like this could transform scientific research, much as industrial automation revolutionized manufacturing, allowing its experiments to run continuously with greater speed, consistency, and efficiency. Wow.
Definitely seems like one of those situations where why not make it open source, because the market for this is probably going to be pretty small. And the better it gets, and the better the people, or the more people improve it and keep it open source, the better it is for these laboratories. So
Yeah.
it's a perfect fit for open source. So very cool stuff. Story number 3, and I hope a lot of breakthroughs come through from that.
Yeah.
Speaking of breakthroughs and
Yes.
vaccines, they're pretty cool. They're nifty little things. Story number 4, this one actually made a big splash in the
Yes,
news,
it
but I'm
did.
glad that you picked up on it as well, because as someone whose parent, because I love throwing around my parents' medical history, someone whose parent just got diagnosed with melanoma like last week, my
Oh,
mom was very interested in this, and I'm like, oh,
oh,
good, you got
yes.
it just in time that they figure out a way to stop it. So good stuff.
Absolutely. Yeah, yeah. And a couple things here. Usually, our fourth story, friends, if you're new to the show, is medical technology related, and this fits that case very well. And most of the time, as Ben often says in his introduction to each show on Friday, these are things that usually don't make the mainstream press, but this announcement was so significant and could be related to by so many people that it did get enormous coverage on radio, TV, online, you name it. What we're talking about, and I just happened to select the story as it was posted in the Reuters news service, but the headline here is Moderna and Merck vaccine cuts recurrence and spread of melanoma, raising new treatment hope. And this is such a cool story. If you haven't heard this yet, which is a little difficult to believe because it's just all over the news, but I did want to highlight this because I think this is so significant. In the show notes, I have a picture of this melanoma tumor on the skin here. And if you have anything that looks like this, friends, please immediately get help because melanoma is no joke, as Ben was alluding to.
If you have that mole that just won't go away, or that itchy spot, there's lots of signs. And
well,
I guess the scary part is there's also no signs. So
there it is. And so, and in the show notes, I thought it'd be helpful to remind everybody about the 3 types of skin cancer, the main 3 types. There are some others. There's good old basal cell, there's squamous cell. Both of these I've had. Melanoma, thank God, not yet. And so you can learn about all of those 3 layers. But here's the big news announced this week. So Moderna and Merck have announced promising results from a large clinical trial of a personalized, this is the key, folks, a personalized mRNA cancer vaccine designed to prevent melanoma from returning. Now, here's the key. It's not a vaccine that you get and you'll never get melanoma. It's designed to prevent it from returning. So that's a key thing to keep in mind, but still incredibly important. The treatment called intismeran, I hope I'm saying that right, is given along Merck's cancer drug Keytruda. Now, Keytruda is very famous and you may have heard about that. In phase 3 trial involving 1,137 patients, that's a big group, with high-risk melanoma whose tumors had already been surgically removed. That was the test group. The researchers compared patients receiving Keytruda alone with those receiving Keytruda plus the personalized vaccine. Wow. I mean, that's, and again, 1,137 patients, Ben. That's a big test group.
Yeah, especially for people with melanoma already. It's not over a period of time. It's like these are the people that have it, so that you are testing for exactly that. It's it was a very good study.
Yeah, wonderful. Yeah. And the vaccine is different from conventional vaccines. Doctors first analyze the genetic mutations in a patient's tumor. So they look at the individual specific mutations, genetic mutations in your tumor if you have melanoma. And Moderna then creates, based on this analysis, Moderna then creates an mRNA treatment specifically designed to teach that patient's immune system to recognize and attack cancer cells carrying those mutations. Ben, just for a moment, consider the astonishing personalization of this. I want to say this again because it's so profound. Doctors first analyze the genetic mutations in a patient's tumor, in a specific patient's tumor. And then Moderna creates an mRNA treatment specifically designed to teach that patient's immune system to recognize and attack cancer cells carrying those specific personalized mutations. Wow.
Yeah, it's and really it goes to show, just like you highlight on the show every time we talk about medical news, and especially when we talk about cancer news, the intricacies, the nuances of cancer. It was always going to take something like this. I know people want that general, just, take a pill, cure cancer kind of thing. But cancer is so strange and evolving and weird. And the fact that they're, able to use mRNA to get to this level, that, that's real hope. That's real hope that, we can get a handle first on melanoma, maybe future cancers. And yeah, this is a great breakthrough.
It is. It really is. And in the show notes, there's a blue text insert to remind you what mRNA is, messenger RNA. If you need a little refresher on that, it's in there. And then the combination of intismeran, again, I hope I'm saying that right, and Keytruda significantly reduced the risk of melanoma returning and also reduced the risk of the cancer spreading to other parts of the body compared to the test group that used Keytruda alone. So that was part of the testing. The companies reported no new safety concerns. This is particularly important because it's reportedly the first positive phase 3 result for an mRNA-based cancer vaccine. However, the companies have not yet released the detailed data of this research testing, including whether the treatment helps patients live longer overall. Of course, that will require time. The full results will be presented at a future medical conference, and Moderna and Merck plan to seek regulatory approval. If approved, the treatment could potentially become available as early as 2027. Given the current administration's aversion to vaccines, I hope their prejudice doesn't prevent this from coming to reality, but keep your fingers crossed. Let's hope.
I mean, a cure for cancer is a great thing to bring everyone together. So
There it is.
that's really amazing. And again, it's one type of cancer, and Ralph, it's still pretty patient to patient specific, but it's an option. It's an option that I guess wasn't there before. So really amazing stuff. Ladies and gentlemen, yeah, those are our 4 stories. And once again, apologize for the technical difficulties. But to head you out, because, yeah, everything's going wrong on my end. But Ralph sounds great. So Ralph is at least going to give you the honorable mentions. And these are stories you want to hear about. Ralph will give you the headlines. Come on out to computeramerica.com and you can find everything right there if you want to come click a link or two. So Ralph, let's do the headlines for the honorable mentions.
Yeah, exactly. And as Ben often notes at this point in the show, it's not that these stories weren't as good as the other stories. We just don't have the time. So we add 4 additional honorable mentions. And the first one comes from the University of Cambridge, their website. Headline, scientists demonstrate solar-powered plastic recycling at real-world scale. That means it's practical and deployable. That's pretty cool. So a little snippet from the article here. Unlike traditional solar panels that generate electricity, the University of Cambridge students created an innovative device that uses the sun's energy to drive a chemical reaction. And the system breaks down water and plastic waste and so forth and so on. It's really interesting. Check that one out. And they'll transform it into chemicals that are useful. Let's scroll down to the next one here. Excuse me. The headline is Copper Drug Restores Memory and Clears Toxic Alzheimer's Proteins in Experiments with Mice. Good old mice again. Comes from Monash University website. That's in Melbourne, Australia. And this is all about how researchers at Monash University have developed a promising copper-based drug that may help fight Alzheimer's disease by restoring the brain's natural waste clearing system. Cool stuff. Check it out. Next one. Here we go. This comes from frontiers.org. Headline, Reinforcement Learning and Control of a Lower Extremity Exoskeleton for Squat Assistance. This is really very specific. The article explores how reinforcement learning, very part of AI, right, can improve the control of a lower limb robotic exoskeleton designed to help people perform squats during rehabilitation. Very specific robotics, all linked with AI. Check it out. I love that story. It's really cool. And our last one here, scrolling down, here we go. Headline is Organic Device for Optoelectronics Collects and Emits Light at the Same Time. Subhead, Organic Device integrates light absorbing and charge transport functions into a single organic structure. This comes from Photonics Spectra. Extremely geeky. Basically, here's the nutshell. Researchers in Japan report a new type of organic optoelectric device that can both capture light energy and convert it into electrical signals, offering a simpler and more flexible way to build future light-based technologies. There you go. And I hope these stories have left you feeling hope for the future in this dreadful news week otherwise, except for the Moderna and Merck announcement. That was wonderful.
And it's really to go to show people that there are amazing stories if you just know where to go. Or if you, hey, check out Computer America every week.
There it is.
Yeah, show you that there is awesome stuff happening. So, Ralph, I want to thank you so much for putting this together and for struggling through this with me. Everyone out there, thank you. And again, we'll have everything fixed by the following week. Everyone, have a great weekend. Do something fun. Catch a movie. And yeah, we'll catch you next time. Until then, thank you for tuning into Computer America. See you next time. Bye, everyone.